Algebra 2, lesson 27. I think initially we had done double lessons on this, but we're not doing a double lesson today. It's just lesson 27. We're going to talk about connecting the parabola with the quadratic function. A parabola is, if we were to look at it on a graph, is either going to look like this, right, where it's going to be like a U shape, and it could be a U shape going down, or it could be going up. Okay. So we're going to look at some things here. I do want to walk through this fairly slowly, just so that you understand what's going on, because there's some important principles here that are, if you understand this now, it's going to make your life, if you move on to Algebra 3, a lot easier. Okay, and my hope is that I'm going to do a better job of teaching it than I have in the past with that mindset. So a quadratic equation is an equation that has a variable that's raised to the second power with no other variable that's raised to any greater power, right? And we've kind of run into different types of equations and how to label them, and we understand that if we have an x squared or even another variable squared, and that's the highest one, that we're going to call it a quadratic equation, correct? Okay. So that kind of hits our first paragraph. They give you some examples here. We could rewrite some of these just so that it looks a little more, official. X squared equals 25. 3x squared minus 8 equals 1. Negative 2x squared minus 8x equals 0. These are all examples of quadratic equations. Okay. There's far more than what we've got written up there. None of those are necessarily written in standard form, but they're there. Okay? The standard form of a quadratic function, okay, is where we have ax squared plus bx plus c, or ax squared plus bx plus c, okay, where a does not equal 0. A, b, and c are real numbers. And because f of x equals y, it could also be written as not just f of x equals, but y equals ax squared plus bx plus c. And hopefully we understand that those a, b's, and c's are just coefficients, right? And my c is my constant. So we might see it as, 4x squared, maybe plus 2x, maybe even minus 3, right? Where we have set off over here equal to 0. Okay, as an example. So have we run into anything that necessarily makes us nervous up to this point? No, we feel pretty good. Quadratic equations. Okay, all right. So another common form of a quadratic function is what we call the vertex form. This is where we're kind of taking your brain and flipping it sideways for a second. Okay, we're going to take that quadratic equation, we're going to change the form of it, something that is equivalent to it. What does the term equivalent mean? Equal to, right? We're not changing the value of anything. Okay, and the vertex form of the equation, and it's written here, but I'm going to write it so that you can maybe make a little bit more sense, is f of x equals a times x minus h squared plus k, right? Let's see, where a doesn't equal 0, and h and k represent the vertex of the parabola. Now, whenever I get over here a little bit later, I'm going to hopefully explain what a vertex is a little bit better. But both the standard form and the vertex form of a quadratic function will be useful. So don't just throw out the quadratic function. But the vertex form allows us to more easily draw a vertex or be able to get to the information that we need. For one, the fact that this a is positive, right? There's not a negative in front of that, tells me that my parabola is going to open upwards. Okay? And the fact that this is a negative h and that is a positive k tells me that the coordinates of the vertex are in the first quadrant. Because this is a negative h, that h is actually a positive coordinate. Okay? And because this k is positive, that's also a positive y. So this is that h there represents a positive x. That k over here represents a positive y. If this had been a positive h it would have represented a negative x. If this had been a negative k, that would have represented a negative y. Okay, so the y makes sense, right? It's positive or negative, right? Which just works, okay? But the h always represents the opposite value of the x. Does that make sense? I know it may not make sense, but we at least know what it does, and every time it does it, we'll know what to do, okay? All right, so the parent function, which is the very most basic form of a quadratic function, is f of x, or y, equals x squared. And the reason that that's basic is that what it's showing me is that my h was 0. Okay, so my x coordinate was 0, and my k coordinate was 0. My y coordinate was 0. So what this is showing me is that, one, it opens upwards, right, because it's not negative, and it tells me that the vertex coordinates are 0, 0. Okay, so I could tell you right off the bat that it's going to look something like that. Okay, with its vertex right there. Okay? Because that's the parent function. Now, what does a itself do? A changes how wide or how narrow that parabola opens up. So, based upon whether or not it's a fraction or a whole number, it may open wider or it may open more narrow. Okay? And I believe, I would have to double check, but I believe as it becomes more of a fraction, the wider it gets. If it approaches a whole number, and the higher the whole number, the more narrow it gets. Okay? The graph of a quadratic function can be found by substituting values for x, finding the corresponding value for y, plotting the ordered pairs, and connecting them with a smooth curve. So if we continue to plug into our quadratic function numbers for x, and we get our numbers for y, we can plot those. If we continue to do it, we're going to see that parabola be able to get connected by those dots. But the curve is what we call a parabola. The graph of every quadratic function. All right, see you. All right, the parabolas of different quadratic functions may vary in width. They can vary in location because we can change where that vertex is. They can change in direction. They can either open up or down, but all have that same symmetrical U shape. Okay. So for the graph of f of x equals x squared, the point 0, 0 is what we call the vertex, and a vertex indicates where the curve changes direction and is the lowest or highest point of a parabola. So if my parabola opens downwards, the vertex is the highest point. If it opens upwards, the vertex is the lowest point. Okay, do you follow me so far? All right. In the vertex form of a quadratic function, hk are the coordinates of the vertex. I've already kind of told you that. Okay. Then we get into the zeros. There's a lot of reading here, but hopefully it's not too complex. Zeros are where we cross axes at. Okay. So zeros of a quadratic function are the values for x for which the function equals 0. It's where it crosses the x-axis at, because that's where y equals 0 at. And y can equal 0 at more than one place. For instance, if I have this and my parabola goes like this, right? It's crossing the x-axis where y equals 0 in two places. Okay, so there can be more than one 0. Okay, there might be just one 0. Right? It could cross right on the x-axis, or there might be no zeros, depending upon where it's located. You follow? Okay. So those are really the only three options. Either a quadratic function will have 2 zeros, 1 0, or no zeros. You can't have 3 or 4, right? Okay. Let's see. The y-intercept is the point where the graph intersects the y-axis and can be calculated by substituting x with 0. In that case, there's only one option. A parabola opening either up or down is only going to cross the y-axis in one place. Okay? At least anything that we're going to look at today. Even if it opens either up or down. Okay, there's no way it can cross that y-axis more than once, opening either up or down. Quadratic function can be used to model a number of real-world situations. When solving real-world situations, it's important to decide what information is needed to answer the question. For instance, the height of an object that is dropped can be modeled by this function. And you'll see this later on in other questions. Negative 16t squared plus b, where t is the time, and we want h to be the ground, or 0. B is the original height of the object is dropped. We want to find the time it takes to reach the ground. You'd want to find the x-intercept where y equals 0, because y represents our height. Okay, so let's look at least a question or two. Okay, so this first one gives me my equation in vertex form and asks me to change it to standard form. What do I do to change this to standard form? We have to do things in order here. Somebody know what we do first? Distribute to 2. We're looking at number 1, right? We do the exponent, right? But we don't distribute it because you're thinking, okay, well, I'm going to get x squared plus 64, right? No, because it's not x squared minus 8 squared, right? It's not, this is not, I can't convert that to this because it's not that, okay? It is this, x minus 8 times x minus 8. How do I solve that? FOIL, okay? So that's going to give me, I'm going to get negative 6 times x squared minus 16x plus 64. So yeah, we still got x squared and we still got 64, but if I don't FOIL it, I'm not going to get negative 16x, correct? All right, and then I still have to add 8 onto that. So now that I have this lower section here, what do I do with that? Distribute to negative 6. Okay, good. So I've got negative 6x squared. What's negative 16 times negative 6? Is it 96? Okay, positive 96x. And then we went negative 6 times 64. Probably negative something. Negative 6 times 64. Negative 384. All right, now let's go ahead and add 8 onto that. Okay, so the standard form of the equation is this guy right here, right? Okay. So when converting from vertex form, first FOIL, then distribute if necessary, then add or subtract whatever's left. Okay? Okay. Now, number 2 is not from this lesson, so we're going to kind of skip number 2. We'll come back to it tomorrow. All right. Now, 3 says, use the graph to find the vertex and its x-intercepts of the quadratic function. Okay? What is, can anybody tell me what the vertex is? What's the vertex? 2/3? I think I know what you mean, but that's not how we would say it. 2, 2, 3. Yeah, 2/3 denotes a fraction, right? We don't want a fraction. All right, we want to know, let's see, does it have, what are the x-intercepts? Does it have 1 or 2? Okay, So is that just going to be a single number, or are we going to write them as coordinates? Coordinates. Okay. Okay. What are the coordinates for the first x-intercept? 1, 0, and 3, 0. Okay. Just looking at it, that's what we would get. Okay. Does that make sense? Okay. All right, so that was just using the graph. We didn't have to do anything with the equation up here to get that. Okay. Let's see if we can do one more question before we go. And of course, some of these were in here. I think B was our answer. Okay. This is a good question to end on, because I think this question shows up in tests. It says a soccer goalie kicks a soccer ball. The quadratic function is y equals negative 16x squared plus 48x. Give the time in seconds after the soccer ball is kicked where it's at a height of 0 feet. How long does it take for the soccer ball to return to the ground? All right, so x is going to represent our time in seconds. Y represents our height. So, I guess we're done. What you would want to do there is you would want to factor out your x and solve for x. You're going to get two values for x. One of them is going to be 0. The other one is the one that you want.